All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 112 is on the screen, and yes, students, unit circle, students. Let's go. So, today there's a faculty meeting for all teachers, so no tutoring today after school. Sorry about that. And I also have a meeting right after this class, so I won't be available during fourth period. Sorry. So stay focused, please. Today's going to go super fast. We're moving on, so copy and go. All right, here we go. Number one. Help me with number one, Lorena, 1A. 1 over 81. 1B, Fabian. You got what? I couldn't hear you with the AC. 64. Thank you. About 1C. Diego Rosas. Square root of 27. Hands if you got that. That is correct. This 3 was inside before it came outside. What was it before it came outside? It was square root of 9 times 3. Square root of 9 times 3 is 27. Number 2. What'd you get for number 2, Joel? Two to the x over 2 to the 5 is what? $32. Number 3. Let me zoom into number 3. You need this coming up pretty quick. Once again, here it goes. We need to rewrite this. This is 125 to the 1/3 power times the second power, because 2 times 1/3 is the same as 2/3. So we focus on this part. What does that become? It becomes cubed root of 125. And at the end, we raise that to the second power. Question, what number times itself 3 times to give us 125? 5. And then we bring the square down, so this is 25. Number 4, sine angle A, cosine angle A, tangent angle A. Share with your neighbor before Ivan shares all his great work for these. All right, Ivan, get us started. Sine angle A. Five over 13. That is correct. How about cosine JP? Help them out, Caleb. That is correct. 12 over 13. How about tangent angle A? Dulce. That is correct. Ooh-wee. Let's go to number 5. unit circle. Students, unit circle, students. This is called the unit circle. Look up, please, because if it's placed on the coordinate plane, the radius, which is this part, the radius measures 1 unit. That's why the coordinate right here is 1, 0. Same thing over here. The coordinate for this one right there is 0, 1 because the y value changes to 1. All right, so unit circle. Where did that come from, Mr. Q? Well, in the unit circle, we can use the radius to move it around. If we move the radius to this spot right here, then we get a right triangle. If we have a right triangle using the Pythagorean theorem and such, we can come up with these coordinates. So label this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. What do we know about quadrant 1? That both x and y are what? Positive. Quadrant 2, the x is negative, the y is positive. In quadrant 3, both of them are negative. And quadrant 4, the x is positive, but the y is negative. Why am I going over that? Because all you have to memorize from this point forward is these 3 values right here on quadrant 1. Check this out. If we start off with the red one, square root 3 over 2, comma 1/2. Well, if we reflect that to the other side over here to quadrant 2, it's the same values except for, what do we know about quadrant 2? That the x becomes what? Negative. Look at the next value. The next value is square root 2 over 2, both. We reflect that over here. It's the same values, but the x is negative. And the last one, if we reflect 1/2, comma, square root 3 over 2 to this side, same values, but except for the x is negative. All right, next. Now I'm going to reflect these down to the third quadrant. Here we go. I'm going to start with the red one again. This red one, I'm going to reflect it right there. Same values, but what do we know? That both of them have to be what? Negative now. Same thing with the blue one. Reflect that over here. Same values, but both of them are negative. And of course, the last one, reflected down here. And guess what? Both of them are negative. That makes sense, yeah? You're like, yes, Mr. Q, I love the unit circle. Good. Then we're reflecting this one now across to the fourth quadrant. And what do we know? That only the y value is negative, only the y value. Same thing with the blue one. The y value is negative. And the green one, the y value is negative. There you go. And that is how you set up the unit circle. Unit circle, students, unit circle. Let's go. We good, yeah? And yeah, this is in the final. Thank you very much. You're like, what? Oh, yeah. Number 33 on the final. You already saw the study guide, right? Yeah? And parents, if you're watching on YouTube, yeah, I gave them the study guide since Monday. They were supposed to sign a screenshot that they're going to turn in today to acknowledge that you know that they have the study guide for an entire month before the final. All right, so do that right now. Turn in your home plate, your signed screenshot, and get a Cornell note ready, please. And those of you following along on YouTube, hold on just a second. Warm-up 112, logarithmic functions, and tonight's home plate, play sheet 16.1, numbers 1 through 12 only. It's already on Canvas, so make sure you go there to get your home plate for tonight. And once again, last night's was pages 771, 772, and also your signed screen. And that's tonight's, only 12 problems. Only 12. All right? So, get a Cornell note ready, please. I can simplify logarithmic functions. I can simplify logarithmic functions. We don't need a fair model because we know what log functions are. Tell your neighbor the definition for log functions one more time just to make sure that they got it. Log functions, definition, valente. Yeah, the inverse of an exponential function. Inverse of an exponential. And then we did some of these, yes. We introduced how to rewrite them and such. Copy this. Log base b to given number b to the m power. Then skip about 2-3 lines. Draw a line across and write example q. Log base 3 given number 3 to the 4th power. Then draw a line down, go to the next column, write log base b to get number b, empty space. In the example box below, you're going to write log base 2 given number 2. One more line down, then you're going to write log base b given number 1, and below that, the example given is log base 10 given number 1. Copy that. All right, here we go. So today we're going to be introducing some properties because we're already, on Monday we covered rewriting the logarithmic functions. We covered solving logarithmic functions and evaluating. Yesterday we got to transformations. Hopefully that was fairly easy to transfer since we did the activity with the Desmos and you are able to see how it moves and all that. Today, properties, we're going to start with a soft intro to 3 basic properties that should have space in your noodle because you're going to need this for the home plate when you finish simplifying. Here it goes. Look up. I'm going to get started with the first one. The first one, we need to first set it equal to y. Write that down. Y equals log base b given number b to the m power. And from there, with all the practice we've been doing, you should be able to go to the next step. What would be my next step? Tell your neighbor, please. Next step from there. That is correct. B to the y equals b to the m. And if that's true, what is y, everyone? Y equals m. Now, this is a mental note property. This is a simple property, and all you have to remember that when you are given a log with a particular base, if that base is the same as the given number, then the answer is the exponent on the given number. So what are you saying, Mr. Q? That we need to show all this work just to get to that? No. From this point forward, if you see this, if your mental note kicks in, you don't have to show me work, just give me the answer. For example, log base 3, is that the same as the given number? Yes, so what is the answer? Tell your neighbor. Y equals 4. That is correct. Write that down. And that's how it's going to go tonight with your home plate. When you get to simplifying, you don't need to show me the last steps like there. You just need to give me the answer once you get to that point if you identify it. Let's go to the next one. Since we already know how to write this down, what would be my first step? Diego Romo. Make it equal to y, yes. So log base b to the b. Continue. All right. So far so good, but we still need an answer. Tell your neighbor what y is, please. What is y? Or let me trigger your noodle. Whenever you don't have an exponent, what do we write? 1. That is correct. So y equals 1. Here's a second property, mental note property. Whenever you are given a log and the base is the same as the given number, if the given number does not have an exponent, the answer is 1. Here's the example given. Log base 2, is that the same as the given number? Yes. Does the given number have an exponent? No, so the answer is 1. Pretty straightforward, yes? Yes, Mr. Q. All right, good. Let's go to the last one. Help me with this one, Diego Rosas. Equal to y. Log base b, given number 1. Continue. Okay, so far so good, but can we leave it like that? No, Mr. Q, because we need to have same basis on both sides. So we got b to the y equals b to the what? Think about it. This needs to be 1, is that correct? Or 1 became this. Tell your neighbor what the exponent is on that one, please. Correct answer is 0. Hands if you got that. Yeah, so y equals 0. Third property that you should have in your noodle, whenever you are given a log, no matter what the base, if it's equal to a given number 1, automatically the answer is 0, such as this one. Log base 10, given number 1, automatically you're like, oh, that's 0, Mr. Q. Bam. All right, those are 3 simple properties that you should have in your noodle ready when you get to simplification if you identify it. If not, then probably you're going to have to do some more juggling around with the exponents. But I do want to get to the actual property that we're going to cover today. We're covering 2 of them. Here's the first one. Write this down in blue. Product property of logarithms. Product property of logarithms. Product property of logarithms. Product property of logarithms. Now, if you think about it, guys, logarithms, we're talking about bases. Is that correct? And we're talking about exponents. So let me ask you a question. Think about this one. If I give you 2 expressions with the same base and they're multiplying, what happens to the exponents? We add, is that correct? So that means our first property should look like this. Log base b given number m plus log base b given number n. So if you have 2 logs of the same base being added, the product property says that we multiply the given numbers. Here they are, m times n. We write both logs as 1 and the numbers multiply. And vice versa. If you are given a log, 1 log with 2 numbers multiplying, then we can rewrite that into 2 separate logs of the same base being added. So once again, if you are given 2 logs that are being added of the same base, what happens to the numbers? You rewrite that as 1 log and the 2 numbers multiply. Okay? All right, let's put this into action. Example number 1. Copy this, please. I left the properties on the top right corner of the screen. And it reads, example 1, express each expression as a single logarithm and simplify if possible. Log base 2 given number 8 plus log base 2 given number 16. All right, so let's do this one together. According to the property, what do we do, guys? Write it as 1. Is that correct? Because these are the same base. So we write log base 2. What happens to the numbers? What do we write? 8 times 16. Continue. Log base 2. What is 8 times 16? 128. Not bad, not bad. Continue. Diego Rosas. Y equals log base 2, 128. Continue, Jose. 2 to the y equals 128. That is correct. I'm going to bring that over here so that I can put it in the center. 2 to the y equals 128. Continue, Caleb. 2 to the y equals, what do we need to have on both sides? Yes, the same base. We just need to find the exponent to give us 128. So let's start multiplying. What is 2 times 2, everyone? 4 times 2, times 2, times 2, times 2, times 2. Okay, so that means 1, 2, 3, 4, 5, 6, 7. So y equals 7. From 1 to 5, how comfortable are you with this so far? 5 fours, 5 fours, okay? All right. So example 1Q, express each expression as a single logarithm. Simplify if possible. Log base 3 given number 3 plus log base 3, 81. Copy and go. So there's the work for that one. From 1 to 5, how comfortable are you with it so far? 5 fours, 5 fours, okay. Send me your notes. Q. Example 1 super Q reads again, express each expression as a single logarithm. Simplify if possible. Log 6, 12 plus log 6, 18. Copy and go. Help me out with this one. Caleb, go. All right, so tell me what to write. 12 times 18. Okay. Continue, Juan. 216. Continue, Isabella. Y. Thank you. Continue, Jessica. Continue, Christina. So y equals 3. Hands if you got that. That is correct. So from 1 to 5, how comfortable are you with this? You good, right? Make a little note for yourself just to make sure you don't forget. If you want to highlight or circle these bases with the same color and make a note over here. What would be the note, guys? If they have the same base and we're adding, what do we do with the given numbers? Everyone? Multiplying. Yeah, this only works if they have what? The same base. So what are you saying, Mr. Q? That if they don't have the same base, we can't do that? Of course. If I gave you log 2, 8 plus log 6, 18, I can't use this product because they're not the same base. That makes sense, yes? So once again, here goes. Quick recap. We started with two logs being added. Since they had the same base, what did we do to the given numbers? They multiplied. Again, we went to the next one. Two logs being added, same base. What happened to the numbers? Multiplied, and so on and so forth. Yes? All right. Thinking time. Then what would happen if I gave you that? Tell your neighbor, please. What would happen if I gave you that? Tell your neighbor. What would happen, JP? Close. That only works if there was addition. Now we have what? Subtraction. Close. Jaden, what do you think? Yeah, of course, we subtract, but what happens to the given numbers? Christopher, let's go. Divide. If for addition we multiplied, for subtraction we divide. This is what we call quotient property of logs. Quotient property of logarithms. And again, vice versa, if you are given a logarithm that two numbers are dividing, you can rewrite that as two logs being subtracted. All right. I'm going to leave these properties on the top right corner of the screen. Copy example number 2. Example 2 reads log 2 or base 2 given number 8 minus log 2 given number 32. We'll do this one together. All right, tell your neighbor how to get started. Good conversation, man. You guys are so social. My goodness. Woo. Woo. All right, get me started, please. Alyssa, go. Yeah, tell me what to write. Eight over 32. Next step, Alessandra. Same process as the other ones. Yeah, y equals log 2, 8 over 32. Next step. Joel, tell me what you write. Eight over 32. Okay. Now at this point, guys, put a little asterisk, a note, and write simplify. Simplify or divide if possible. Can we simplify this to lowest terms? Yes, Mr. Q. What is 8 over 32? 1/4, yes, that is correct. Next, 2 to the y equals 1 over 2 to the what? Very good. 2 to the second. Now, are they the same base? Almost. This is a fraction. To get it out of the fraction, we send it to the numerator. And tell me what to write, Diego Romo. 2 to the y equals what? To the negative 2, yes. So y equals negative 2. All right, send me your... All right, help us with this one, please. We can go a little bit faster. Diego Rosas, go. Log base 4. (128) divided by 8. Continue. Which is? Uh-huh. All right, hands, have you got that? From 1 to 5, how comfortable are you with properties of logs? Okay, not bad, not bad. All right, send me your notes, please. Should have the screen already there. Okay. One more slide. And I'll stop the video right here. Once again, no tutoring after school. We have a meeting. Enjoy your home play. Bye.